My name is Melissa Chalpont. As she said, general partner at Inventures. While I am an investor, I'm not your investor, right? So I always said my opinions are just mine, and I tell a lot of the companies that I work with. We have our own thesis of what we invest in, and that's a little bit of an insight why I put this panel together. I brought some friends of mine in to talk about quantum computing, yes. Also, this thesis came from a visit that I had at UT in the Rio Grande Valley. We were on the manufacturing floor. The thesis for my firm, we work with physical applied AI, but with physical product, right? So when people say AI, and to Colin's point, a lot of people put AI on the back or on their deck when investors are looking at it and they're looking for that extra zero, right? Those of us who have been in this industry for a while, we look for the application. So we started hearing a lot about what we invest in is we're investing in the future, 5 or 10 years down the road. So quantum, the word quantum started being applied. And so when this panel came together, I wanted to let you know a little bit about quantum and how that application applies in manufacturing. So with me today, I brought Michael Pendleton from the AI Cowboys. I brought Nic Villarreal from Mekifi. And I brought Dr. Pryor, professor here at UT, director of the Robotics Center of Intelligence and director of Nuclear and Applied Robotics. So thanks for coming, y'all. And I'm going to spend just a minute letting them introduce themselves, and then we'll get into it.
Thank you, Melissa. As you mentioned, I'm Dr. Pryor. I'm the head and co-founder of the Nuclear and Applied Robotics group. We are a group at UT as a part of Texas Robotics, which currently has 17 faculty, our whole own building. And our push is really to take some of the great things that happen on campus and push it out into industry and for work in the domain. The Nuclear and Applied Robotics group, our funding comes from the Department of Energy, a lot from Los Alamos, a lot from the oil and gas industry, putting robots in offshore areas. We've got money from the Department of Defense and the Space Force. And in all these cases, it's really about putting those robotics in places where we really don't want to put humans. And the key, I would say, to our success in this area is the inclusion of researchers who don't just know robotics and AI, but also understand the domains that robots are going to be going into. In nuclear, they're going to know an alpha from a beta from a gamma. In oil and gas, they're going to know what a D1C1 certification is. And that is what allows us, I think, to find more success in getting those robots over those difficult parts of the transition. Thank you. Very good.
I'm Nic Villarreal. I am the president of Mekifi Automation. We are a manufacturing automation integrator. So we put robots and AI into manufacturing facilities for a living.
How's it going? I'm Mike Pendleton. I'm the founder and CEO of the AI Cowboys and Quantum Cowboys. We are out of UT San Antonio and the National Security Collaboration Center. We have a strong background in education and technology, as well as government and industry solution and research and development, to include a lot of funding from Department of War, DARPA, the AFRL, Syracuse Research Board.
So one of the things we noticed, I was visiting the UT in the Rio Grande Valley. I said we work on manufacturing, putting autonomous drones in the air. We do innovation with mobility, innovation with autonomy. What I noticed is that we had the mechanical engineers, we had the electrical engineers that were on the floor, but what they had behind them was the computer science engineers, right? And so they were quietly observing the process of putting a manufacturing line together. And it occurred to me this is applied AI in real world manufacturing. But I wanted to start by level setting for those. I know we have a lot of people online, so I wanted to make sure that we level set quantum. So I'm gonna hand the mic over to Michael.
Can you, sorry, quantum. I forgot to ask the question. What is quantum?
Yeah, no, so it is quantum. We get that all the time. I want to preface what I'm about to say with I'm not a physicist, but I'm not a mechanical engineer or an electrical engineer as well. I have a doctorate in engineering, AI and ML engineering. So I'm an AI engineer. So it's from the Ivy League school, so it'll count. No, so what is quantum? So I learned how to program in quantum and have a couple evolutions on actual processors. So quantum, if you think about AI and you think about pushing, complex problems through a neural network or a layer, right? It'll do it at an accelerated rate, one after another after another. With quantum, a way to look at it and a way to frame it is, it'll solve billions at a time. So the example I like to use is Google's quantum processor, Willow. Right, so it took, Willow ingested a math problem that would have taken a supercomputer 300 quintillion years to solve, and it solved it in just over 4.5 minutes. And so that's that right there in itself is a key framing on how quantum can significantly accelerate, from classical computing and AI and machine learning, right?
Okay. All right, so,
Level set quantum, so faster computing. Right, let's see, Nick, if you could tell us a little bit about how AI is applied to robotics and automation in manufacturing today.
Okay, is this one? Yep. All right. So today, AI is used in a lot of different sort of neuro automation, the AI that we think about the most advanced stuff, which is still a level below our large language models. It's the AI that can take an image and recognize what's going on if we teach it. So we have a lot of vision systems. That's where it's the most prevalent, right? So you give the robot a picture. It takes the picture, the camera takes the picture, and it says, here's the picture, and you box it, and you say, hey, look, this is a significant area of the picture, this is what it should look like, or this is the shape of it. And from there, it will know what to look for and what's good and what's bad. So you can use it for inspection, you can easily teach it what's good and what's bad, and then it will tell you that things are good and things are bad. And if it's wrong, you give it one simple correction, and it'll be right from then on. So that it's a huge leap from the previous vision systems where you say, I need a cluster of red pixels here in this area, or it's bad. And it gets confused with anything else that might distract it, that's also red, and the lighting changes and all that. AI actually makes it a lot easier to install into the factory floor. So that's vision systems, that's how AI is used. That same camera can be used to recognize the factory floor for a moving cart. So if you have an AGV or an AMR, the ones that are autonomous and they go by themselves, you can walk it around and it will recognize the factory. You look at the screen and you'll see it mapping the factory floor for you. And then you can draw a path in that factory. Next time it comes back there, it will recognize everything around it, and it will avoid obstacles and things like that. So that vision system controls that mobile cart. And then of course, cobots, collaborative robots, which work around people. It won't just injure somebody. It'll stop when it reaches them, or it'll sense that human's near, and it will actually stop moving rather than hurt the person.
Dr. Pryor, your robots operate in some of the toughest settings, from defense, nuclear, and energy. How is computer science advancements making manufacturing more autonomous and more capable?
Thank you. In a lot of those remote environments, things have to work no matter what. So we still leave strong guardrails around the robot that are much more deterministic. We don't do a lot of the end-to-end machine learning. Where we do use it is to solve subsets of problems that just 3-4 years ago might have been a whole PhD, but now is a simple problem to even a local LLM. For example, at Los Alamos National Labs, we needed to put robots in to do alpha radiation survey. I thought that moving the chairs and the trash cans out of the way for the other robot to come in and sweep would be its own PhD problem. How should a robot pick up a chair, and which direction should it move it away? That is now solved by a local small language model that we can get done in that place. And when we test it now, when we see that it's able to make a decision in the order of seconds or maybe even a small number of minutes, that's where kind of quantum and the acceleration comes into mind. Since we're at a low TRL, recognizing that these things are going to get faster means that doesn't bother us as much. The second area where we see a lot of it is in optimization. We put robots in glove boxes to do manufacturing. The robots are not going to hit the windows. They're not going to knock the things over inside. They don't keep things far enough apart from each other that the manufacturing processes can be safe. But when a manager comes in and sees the robot sweep by near the front glove box window, immediately gets scared that it's going to knock out the window. So we use reinforcement learning on the back end so that it selects paths for the robot that look safe. So we call it looks safe is safe, or feels safe is safe. And so that idea that AI can have a positive, beneficial impact, even while we keep strong guardrails in place on the back end, is a great way to see AI get those toeholds that are necessary in these environments.
That's great. Mike, do
Do
you
you
have
have anything to add here with how you're integrating into the manufacturing process?
Yeah, I think Mitch hit the nail on the head with the, so there's a quantum assumption optimization model of algorithm, right? And so I think, recently we've been exploring the use of edge AI, neuromorphic computing using brain chips and use of spiking neural networks. So I think as you see technology and engineers evolve, to Mitch's point, at the speed of relevance, you'll see, instead of those traditional convolutional neural networks to carry the object detection piece on the manufacturing floor, they'll slowly turn into, as kind of energy can't be printed to the previous person's point. You'll see that turn into a spiking neural network through the use of, frequencies and some neuromorphic computing on edge devices, which will, significantly decrease the energy used and significantly increase the accuracy of the object detected.
So when it comes, this is for anybody, when this comes to safety and accountability, we talked about this a little bit, what practices are key when deploying autonomous robotics in critical environments?
So this is for anybody.
I'm going to ask this to Nic right afterwards because I think we had two different answers to this where he said there was no standards or regulation. I was like, they're all standards and regulation. But it's because if we're going to put a robot in a research refinery, in the United States at least, I still have to maintain a D1C1 certification. I need to be explosion proof. And that is a high bar for a autonomous system where the intelligence for it is literally a black box. How can I guarantee this any more than I can for a human? And what is the threshold that I need to meet in terms of that? So there are, in those environments, I've seen other places, Australia has been more permissive, allowing methane sensors and other things so that robots can operate, and if there's the presence of humans, they just shut themselves down. So I think there are ways to get around that. So the first thing I would say is that anytime you talk to a manager, they know the regulations and compliances they have to be compliant with, whether it's a robot or not, and those do not go away. You see that with the FAA when you're trying to put robots in airports. You see that with the NRC, trying to get them to certify some of those robotic systems when the regulations specifically call out use of humans. Those are really challenging environments, and those are things that can be solved possibly technically, but need to definitely be in collaboration with folks. But I'm going to let Nic comment on how, from a robotics point of view, it's probably still a bit of a Wild West.
Yeah. Back to this mic. So yes, let me clarify. I'm coming from the other direction where if AI brings new capabilities to robots, are we going to allow these new capabilities to stand and not be guarded, right? Can the AI of the robot actually allow it to work around humans without injuring somebody? And how are we going to know that? We need some regulatory agency to do some studies and direct us and tell us we cannot do something or we have to do something with regard to safety for these robots, right? So as things get more intelligent, we'll start to learn what are our limitations to this intelligence and what do they buy us? What new capabilities can we get? For example, maybe we can build a whole car in a factory with only robots and have people walking in between them. Like, we cannot do that right now. Maybe this will allow us to do that, but we need to be absolutely sure about it. So we need to have every expert, who's in charge of studying these things, making sure it's safe for us, telling us what they recommend, and then of course each individual facility they have more stringent requirements than the government regulatory agencies. So each individual facility has to say, we'll allow it, or we won't allow it, or we don't really know, somebody help us.
And who would that be that could help us? Is it the computer scientists? Do they help write policy? What do you think about this?
I'm sorry, say that again. I was in safety, man.
Oh,
Yeah, Cowboys, we
exactly.
never put safety in a corner. I just want to point that out.
How can it shape, how can quantum computing shape the safety protocols?
Yeah, no, I think and that's a great question. You know, I think the ability to exceedingly fast in a whole different dimension, identify safety parameters, billions of them all at once, and be able to come up with, you know, I guess see roadblocks before you encounter them, I think is very powerful.
Right, absolutely. It's very good for you all to spec on. All right.
All right, so I think we've got another one here, what types of partnerships or pilot programs can help manufacturers adopt some of these automations more efficiently? What types of programs are out there to help your worlds blend?
Sure. Anything that helps early adoption will help this. It's the early adopter phase of AI. Anybody who's willing to take a little bit extra risk, not necessarily safety risk, but monetary risk or time risk or other types of risk to push something forward to make something happen. Right? So it's the early adopters, and then a lot of times it's supported by universities and government agencies. They put either the labor, the thinking, the brain power, or the monetary investment into getting these things adopted.
There's been a real transition in my group, and I think with other groups within the universities, to hire more full-time staff and engineers to support the efforts of the students. And what this has really enabled is the university's ability to participate more enthusiastically and more effectively in programs like SBIRs and STTRs. What this allows us to do, I have multiple companies that we're working with, where now a phase one in those type of environments, which is typically a small amount of money in a short amount of time, 3-4 months, never makes sense to involve students. They don't know enough to really help and put that together at that point. But with the engineers coming in, a student has an idea, an engineer is graduating, they're able to then work with a company that sees the potential value and now has an ability to pay their engineer to actually invest some time in those things, to then adapt that and make it into a phase two and see the thing really survive. So I think, like in my group right now, I've gone from having 1 full-time researcher and a bunch of students to now I have 9 full-time researchers and still a lot of students. But that allows us to engage with a score of companies that see things that they like and now see a much better path to transition where they can support and provide industry endorsement for these ideas with government funding without them having to fund the high-risk stuff at the university directly themselves. So that's definitely one path. I also have talked to more VCs and venture folks in the last 5 to 6 years than I ever had previously. So I do think that there are folks that are seeing a lot more opportunities out there through connective tissue that's created by events like this.
Yeah, you know, 2 very great answers, and I would also add, you know, just kind of a triad, you know, identifying audience when you get, you know, government, academia, and industry all in sync to be able to create these partnerships and collaborations, and, you know, each of them is bringing something to the table, whether it's researchers and engineers from academia, you know, industry bringing in, you know, cloud time, GPU time, et cetera, and then the government bringing in, you know, complex projects to, you know, to solve. I think that's a very harmonious sync of what can happen and how it can move forward. And again, compliments to, you know, events like this for providing those synergies for the folks here and online as well.
Right, I'll echo that as well. I think that we call it capital stacking, right? In my role, it's how can we utilize our funds and amplify those, working with research institutions, working with universities, working on grants together. It's a huge opportunity that we have here to get physical product going, to get early ideas funded by capital stacking and working together. So the collaborations that are coming together here recently are helping us advance in a rapid.
Yeah, and, two very great answers, and I would also add, just kind of a triad, identifying the obvious when you get, government, academia, and industry all in sync, to be able to create these partnerships and collaborations, and, each of them is bringing something to the table, whether it's researchers and engineers from academia, industry bringing in, cloud time, GPU time, et cetera, and then the government bringing in, complex projects to solve. I think that's a very harmonious sync of what can happen and how it can be moved forward. And again, compliments to, events like this for providing those synergies for the folks here and online as well.
Right, I'll echo that as well. I think that we call it capital stacking, right? In my world, it's how can we utilize our funds and amplify those, working with research institutions, working with universities, working on grants together. It's a huge opportunity that we have here to get physical product going, to get early ideas funded by capital stacking and working together. So the collaborations that are coming together here recently are helping us advance in a rapid pace. And so I think that's a huge opportunity here for Texas, especially too. Sorry, I'm juggling these glasses, which is really annoying. All right, so I think that Dr. Pryor, what breakthroughs are still needed to be made in order to have advanced robotics routine across hazardous industries?
Oh yeah, super easy. I'm going to answer this with sort of a stock answer that I get, that the next big breakthrough in robotics will not come from a roboticist. The next big breakthrough in robotics will come from mechanical design of a better grasping device, because that's definitely an area that there's still some challenges. I've seen some new ones in the field. The breakouts then come from better battery technology, or more dense motors, or in the case of drones, quieter motors. If we're not paying attention to the components and the sources and the materials, I joke a lot that high school robotics teams have really helped a huge influx of Americans come into the technology in the areas, and it's a giant, and I'm going to say this in front of who knows, the wrong people, but it's a bit of a bait and switch, because they come in and then there's not a lot of robotics at the underground, but everything they're working on, whether it's materials, controls, circuits, whatever, is where we're going to see the improvements in robotics. So we cannot forget that foundation as far as that goes.
Mike, tell me about the hardware that will help advance us. That was right up there anyway.
That's a tough one. Yeah, there's a bit of a race between competing, I'd say, global interest in the hardware and the architecture for especially quantum processing. The room temperature versus the different. So treading carefully, what I say and how I say it. I think it's unique and interesting. We have a strong partnership with NVIDIA and Mr. Tim Costa. He's in charge of NVIDIA's quantum and high processing computing department. So we have a strong partnership with them, and we chat. And I think it's interesting to me how each company, whether it's IBM or NVIDIA or whoever, is headed in a different direction with quantum. And I think it's also very interesting how they all think they're right. I couldn't be more disinterested to an extent, and then on another extent, I definitely could be very interested because, as I said before, for those of you that weren't in here, I'm not a quantum physicist, I'm a quantum programmer. And so I'm very, I'm very partial on the hardware. I think you'll start to see some quantum-inspired hardware come out here sooner rather than later. I also think, kind of to jump to the previous question, a lot of folks talk about AGI, or artificial general intelligence. From a very AI and machine learning engineering perspective, AGI is a stepping stone, just so everyone knows. A lot of folks look at it as a destination, but the destination is ASI. And when we achieve artificial superintelligence, it's going to be a completely different world that we won't recognize, and I hope I never see it in my lifetime. And this those advancements, and by the time people get their minds around, AI and what is this AI stuff, quantum's just gonna blow their mind. I would also suggest, to the previous thing, because this is really hard for me to not say, I think if AI is a bubble, it's been one of the longest bubbles in the history of the nation since Hinton came in 56, the spring of 56, I believe, and officially established it as a research vertical. So AI has been going on as a bubble since the spring of 56. So it's been a long-standing bubble. To kind of add on to that, and I promise I'm gonna give the mic up. So to add on to that, I would just say that, I think where we're at currently is kind of the same with the internet, right? When .com bubble came out in the late 90s, early 2000s, it was a thing, and then we just kind of leveled out and realized the internet's gonna be around forever. I would say the same with AI, right? I think we're just at a time where the unicorns are marketed really well, and it's inflated the market. And all the money in AI is in the hyperscalers. And so that's, I'm not a financial advisor, but that's my financial advice, because the AI lab's burn rate for capital is atrocious. And we have an AI lab at UT San Antonio, so, by the way.
Yes, please, and closing thoughts too.
My bad.
As a closing thought, I'm going to ask you a question that's going to have a very specific answer. Just this morning, some of my students did a really cool demo around deictic gestures. And deictic gestures mean that both the voice and your gesture are necessary. So if I said, go down the aisle and then take a left and then go out that door, then my pointing lets everybody know it's that way, my left, not your left, and that door, not that door. When the robot did this demo for me just this morning, it was very exciting, the deictic gestures. The robot, after hearing the command, paused and waited about 50 seconds to a minute before the BLA model had processed the answer and began to execute. I told the student who was self-conscious about that, don't worry about that. That's going to get fixed in the next whatever. So in 5 years, when this AGI comes along, how long is that pause going to be?
Less than 10 milliseconds.
Okay. I'm going to tell them not to worry about it.
No fret, little fella.
Y'all, this has been great. Thank you so much for having us, David. Great event. We appreciate you. And thanks, y'all.